Welcome to day 4, product rule. Today we're going to look at a different rule, how we handle when functions are multiplying each other. The last couple of days we've been doing chain rule. That's when we have a function inside of a function, or multiple links in a chain, a function inside of a function inside of a function, and so on and so on. Product rule is when two functions are multiplying each other. So my example is right here. H of x equals x times sine of x. This is two functions multiplying each other, or the product of two functions. X is multiplying sine of x. And here's the difference. If we had y equals, let me try. If I had y equals sine of x times e to the x, this is a product rule. But if I have y equals sine of e to the x, this is a chain rule. This is a function inside of a function, and the first one is a function multiplying another function. And to me, the big giveaway is that you're going to have the variable x a couple times multiplying each other. So when I look at this, this is the graph of x sine of x. I just put this in the calculator, I printed it out. It's a weird looking graph. It is an even graph, but I want to determine the derivative. So going back to what we first learned about derivatives being the slope of the function, I can go through and find, well, all these points, all these mins and maxes will be the x-intercepts on here. Carefully drawing them. So those red dots are all the x-intercepts, or the where the slope was 0 here. So all these slopes are 0. Well, this slope here is positive, 0, negative, 0, positive, 0. So I could fill in all these slopes. Positive, 0, negative, positive, negative, positive, negative, positive, negative. It seems like it's getting steeper and steeper every single time. So maybe the graph would be something like this. Okay, to the best of my ability. So for me, how do we figure out the equation of that red graph? That's where it gets tricky. So we're going to have to do a process. I'm going to make it very mechanical, like I did the chain rule, and we just set up derivatives, and we have a very basic rule on how we do things, and it's not that hard. It's different than the chain rule, but I'll go through that process below. So if I have a function that is a product, one function times another function, f times g, my product rule says the derivative is equal to, you basically have a couple of things going on. It is the derivative of the first function times just the second function, and then just the first function times the derivative of the second. Okay? Or you could go the other way, you could go whatever way you want. The key to this is that we have a derivative times a function plus a function times the derivative. And you could reverse the order because it's just multiplication and addition, and it doesn't care the order that you do things. So another way to think about this, I'm going to change color. So I have my function f, and I have its derivative, and then I have function g, I have its derivative. All I'm going to do is do a crisscross. And it doesn't matter which way you do first, but I tend to do this way first, and then I do this way second. But you could do the other way, it doesn't really matter. If I do a crisscross, if you notice, when I do the black crisscross, I get y prime equals f prime times g, plus, don't forget there's a plus sign in the middle, and then the blue crisscross is f g prime. So for my example, my two functions that I have here, x sine of x, well, I could split it in half. Here is the f part, here is the g part. So I have x is one function and sine of x is the other function. So let me set up my crisscross. The derivative of x is 1, derivative of sine is cosine of x. And I'll do my crisscross. I'll do this guy first. You don't have to, you could do the other one first. I get h prime of x equals sine of x. When I do that crisscross, plus, and I'll do it the other way, plus x cosine of x. Now, I don't expect you to know what that graph looks like. I don't even know what that graph looks like. I would have to put it in the calculator. But the idea is that this method is how we're going to handle product rule. Okay, I'm going to use product rule again. It looks like I have two functions multiplying each other. I have 5x cubed is multiplying e to the x. I can split it down the middle. Here's my f, here's my g. And let's find the derivative of each. Well, f equals 5x cubed, and its derivative is just 15x squared. And g equals e to the x, and its derivative is just e to the x. Easiest thing of all time. Let me do my crisscross. So I tend to do this one first. So dy over dx, also known as y prime, is equal to 15x squared e to the x, plus, now when I do my crisscross the other way, 5x cubed e to the x. And that is your derivative. Okay, it's not too hard. Like I said, I'm making very mechanical like I did chain rule. So how are they different? How is chain rule different than product rule? Well, chain rule is when we have a function inside another function. Y equals e sine of x. That is the sine function inside the e function. And notice I really only had the variable x one time, where product rule is a function multiplying another function. Wow, that's messy. Another function. Y equals e to the x times sine of x. Notice, I kind of have both examples have e function and the sine function, but one has sine inside of e and the other one has sine multiplying e to the x. And I see the variable x two times. They're multiplying each other. Okay, let's try some examples. So if I set this up as a product rule, my first function is 2x plus 3, and its derivative is just 2. The second function is x minus 4. Its derivative is just 1. Notice I put parentheses around things when it's more than one term. I'm going to do my crisscross. I'm going to do this way first. Y prime equals 2, parentheses x minus 4, plus, now we'll do the other way, 1, parentheses 2x plus 3, I'm going to clean this up, I get 2x minus 8 plus 2x plus 2, I get y prime is equal to 4x, that's 2x, oh that's a 3, my bad. Can't even read my own handwriting. 2x plus 3, it's 4x minus 5. that is its derivative. Now, what I could have done instead, I could have taken this problem, unfolded it out, and if I would have done that, that would have been y equals 2x squared minus 8 plus 3 is minus 5x minus 12, and oh, look at that. I could use my power rule and I got the same derivative. But I want you to practice product rule. This one I definitely have to do product rule. There's no simplification for this. So my first function, well, let's see, it's right down in the middle here. My first function is negative 6x squared. Its derivative is negative 12x. My second function is sine of x. Its derivative is cosine of x. I want to do my crisscross. F prime of x equals negative 12x sine of x. Notice I put that coefficient up front. I put the x up front. And then plus, but it's really a minus, minus 6x squared cosine of x. That one was much easier. Not a lot of work to do. Notice, when I write things out, I should do the number up front, x to a power, if I have that. Maybe stuff in parentheses, so power in x. Then we'll talk about sometimes we have e stuff, then we have trig stuff. Okay? Maybe we have ln stuff too. Maybe once in a while, we'll see. Okay, now we're going to do problems that are definitely product rule. I do see a function times another function, but maybe chain rule is also involved. I think these examples all have what I call that mini chain rule. So if you look at this example here, my two functions are 4x squared, and the other one is cosine of 5x. Now technically, I would have to do chain rule on this guy, but hopefully you see it as a mini chain rule. Well, the derivative of this is 8x. The derivative of this is going to be negative, well, sine of 5x. But this 5 causes an extra 5 to be here. That's the mini chain rule part. That's what I want you to pay attention to. Okay, now I'm going to set up my crisscross. I do this guy first, so h prime of x equals 8x cosine of 5x, and then plus, I do the other way, and technically it is 4x squared times negative 5 sine of 5x, but that doesn't really look nice, because what we should do is multiply out these coefficients. So I really get h prime of x is equal to 8x cosine of 5x minus 20x squared sine of 5x. You need to multiply things out. Okay? Numbers multiply each other, called coefficients. Okay, the next example, again, I have this mini chain rule. I'm hoping that when you see some of this stuff, you see 2e to the 3x. Yes, there's a chain rule involved, but you should recognize it's just 6e to the 3x by the mini chain rule that we talked about yesterday. And sine of 4x, just into 4 cosine of 4x on the same mentality. Now when I do my crisscross, I'll do this guy first. G prime of x equals 6e to the 3x sine of 4x plus, and when I do the other way, I have to remember I have coefficients involved. I see a 2 and a 4, so it's going to be 8e to the 3x cosine of 4x. Okay? It's not that hard. You don't have to do anything more than that, but you do have to multiply those coefficients. Okay, well, I guess I could split this in half. I have negative 2x cubed, derivative of negative 6x squared. I have ln of x. Its derivative is 1 over x. Do my crisscross. I'll do this one first. Y prime equals negative 6x squared ln of x. And then plus, but there's really a minus 2x cubed times 1 over x. And I have to multiply this out. Negative 6x squared ln of x minus, well, one of the x's will cancel out, 2x squared. That's my final result. This is the other crisscross. Last example. This is x to the 2/3. You rewrite it correctly, and 2/3 x to the negative 1/3. This is sine of 6x, and by mini chain rule, 6 cosine of 6x. I set up my crisscross. Like I said, I like to do the bottom left to top right first. Y prime equals 2/3 x to the negative 1/3 sine of 6x plus this coefficient 6 comes first. 6x to the 2/3 cosine of 6x. Okay. That's product rule. Very different than chain rule, and sometimes I have chain rules inside product rule, but this is a very well doable process. Ask questions in class. Thanks.